Well, good afternoon, all. Good afternoon. At the entire class is there is only one person in the class. What about the remaining? Well, so hoping that at least I'm audible and my screen is visible, right? Hope I'm audible and my screen is visible.
Yes, sir.
Good. Thank you. Thank you. Wonderful. Right. So, before I proceed for today's session, let's just recall what we discussed in the previous session. So in the previous session, so we were discussing on mainly on a portable devices. What is meant by portability? What are the uh, main opportunities, the quality attributes of them, right? So which are the devices are said to be the portable devices? On what criteria we say portable devices? One of the best example is always that our mobile phones, right? Mobile device, which we may majorly consider, right? So which will be small, which will be we are holding on a hand. So a small display is there and a miniature keyboard will be there, or it could be a touch screen, right? So many things are there. So similarly, we should have so many quality attributes of those devices, which is ubiquitous, right? So portable things will be there, versatility of those the different applications or the softwares, and there's a lot of challenges which is opened up for us to allow the explore and develop, right? So there's a lot of things which is there, so there we need something, some way to learn to make utilize of these things to build better applications, better software, and better technology, right? So it's a design. What will you do? It will be one time and you're going to make it alive, right? So things like there's a lot of opportunities for that to go for creativity or innovation, application advancement, right? So it will be making it easier, right? So there's a lot of things are there, and so many attributes of them we discuss, and a software platform for that what is required, right? So these things, so what they we discussed, right? likewise we discussed about various embedded systems and other things, right? So let's, with those knowledge or the basic things what we understood, let us proceed for session today. So where we're going to talk about, uh, in the session one, we had typically gone to this the design, the hardware and product design, schematics and product design notes and applications for discussion, and then wireless interfaces, things like so. To portable devices, portability, key characteristics, right? So all these things we discuss. And for today, before we proceed for our session, so these are the lectures content what you're supposed to go. It little history and various hardware platforms, which include processor, peripheral devices, and sensors, mobile phones, and the wireless devices, or the platforms for them, and IoT and the wireless and portable devices and use cases of those things, as well as the a little set of applications, and then a platforms which is Sojan. Now, majorly we this session we will be going through this hardware and the product design, especially considering a motherboard which is called as Raspberry Pi. So an early Raspberry Pi 1 model, which is more, which was a small in size, which comes with a processor and everything together, which has an HDMI port and a standard RCA composite video port for the older displays were there. Okay, so later it was been completely modified so that it can be used with advanced technology, right? So where the diagram which you're seeing here, you can easily look into that. There is a thing which is able to connect to audio, video, right? And you have a connectivity for network also, right? So everything was there, and there's a IO operations which you can see. These are 26 IO pins were there, general purpose IO pins were there, so that you can able to connect to the external world or external devices. Later on, those things were modified to a little other extension so that it can be used with a HDMI port also, so that they can connect to a displays. Now, this is the components of this Raspberry Pi, right? So first part of that, which you look at, is this the system on chip, where you call it as a processor, right? So where all things which can be processed, so that we'll be using it as a processor there, which can run with an operating system which is required or general purpose. Then you have this micro USB to get connected to that and transfer the data and to and from, right? SD card slot for having extension of memory, and display connector for that. So if you want to get connected to the display so of anything as to a monitor or to a screen anywhere, and then P5 header. So there you'll have a general purpose IO pins are there, and video outputs which you want to get connected to the display. And then there is a JTAG pins are there. So output for audio to be connected so that you can listen to the audio. LED sets are there where it's going to display the LED information. Right, so this is LED set, and this is a USB controller where you will have an option of connecting multiple USB slots from through this device. So which is to get interface and then have a communication, right? So that will be taken control by this device. And this is used for your internet connectivity or LAN connectivity. So where you can connect a RJ45 connector through which you can perform the communication. And you have a camera to be projected, right? So if you want to have a camera like which you for any laptops or things like, if you want to get connected, so you can use this CSI camera connector, right? So this is for getting connected to a display through a HDMI cable. Right? So this is called as your processor, where all your instructions will be processed one after the other. So there's a lot of variations or the versions of this Raspberry Pi exists, right? So Raspberry Pi 5 is the latest one which you can think of it. So which comes with if you have that, so that it is nothing but you have a miniature computer with you. So that's what I can say with this, right? So easily you can get connected to a anything and you can perform anything with that, right? So this is Raspberry Pi, Raspberry. This has been used to get a process, right, to programming it and just have some interconnection of sensors and the other things so that you can get the moisture of the on the soil or the temperature or anything as such which you have. So you can program it, you can get the data, and you can display it. Right, so there's a Raspberry Pi 4, right? So there's a thing which is getting attached with the camera also. So there is Raspberry Pi 2B uses which comparatively Raspberry Pi 1A model, which has only 26 IO pins, so that you can have limited, that the connections or to external world is limited. So you need an extension of that, which comes with a 2B, which uses a 32-bit 900 megahertz quad-core RAM Cortex A7 processor, which has 40 40 general-purpose I/O pins were existing. So there's an extension so that you can have more devices get connected and perform. So there's a block diagram for any of them you take a model B, B plus, A or A plus plus, so A plus. So all of them will have a common thing with that. What is that common thing? So you'll have a CPU, right? And the CPU to get connected to process anything, the data has to be fetched from RAM, right? And it has to be connected to the IO so that it can get communication with this, and all the instructions which you want to process, that has to be stored into the RAM, and you have to fetch it from there and execute it, right? And at the same time, you need to connect it to the external world through USB, maybe for a storage purpose, or maybe for a programming purpose, whatever it is, or you can have an Ethernet connectivity, so that all those things will be able to get communicated through a CPU, right? So this is a Raspberry Pi 3 model, right? We just so these are all said to be the general purpose IO pins for interfacing with other devices. So which is a RAM and a CPU, which is inbuilt here, right? So this is an HDMI connector, which is used to get connected to a display. So this is for USB controller, and this is a RJ45 Ethernet connector, right? And this is going to give you the status signals through LED thing. And this is an audio output, and this is a video output for older systems, right? So you had a power supply connection, and this is a slot which is going to show you here to extend your memory capacity as a secondary memory if you want. So you can have a SD card inserted over there, so you can have extended memory. Right. So when we have these models, we have so many different models are there. Pi 1, 2, 3, 4, and 5 models are there. So we will be having comparison of that with various factors here. Right. So let us just go on with understanding each of them. Right. So when you talk about a processor, right, all of them has a Broadcom processor only. Right. So with the clock speed is going to be varied accordingly. Okay, so if you can see this Broadcom BCM2835 for Raspberry Pi 1 model, and then 2836 and 2837B0. Okay, so which is an extension of Raspberry Pi 2 model, and then Broadcom BCM2711, Broadcom BCM2712 is a latest version of Raspberry Pi. What is a CPU type? It is an ARM processor or other processor. So it is an ARM processor 11 and Cortex A7 in Pi 2, and then Cortex A53, A72, A76 are the which are all ARM processor, embedded ARM processors are used here. The architectures will vary, which can be 32-bit for first two models, and then later it will be 64 bits for 3, 4, and 5 also. And the number of cores, the processing cores in the CPU has been expanded in all the models except the one. So the Raspberry Pi 1 model has only one single core processor, but whereas Pi 2, Pi 3, and Pi 4 all have a quad core processors. So there's a general purpose, graphical processing units which also exist in all of them, right? So video core 4 and video core 4 is all of them, and then for 4 and 5, it will be 6 and 7 respectively. Okay, so RAM capacities which can be varied. Initially it was 512. For the second version it will be 1 GB, and the third version also 1 GB. But whereas Pi 4 supports up to 8 GB, and whereas 5 will support up to 16 GB RAM. Okay, so so according to the computer structure, RAM is a primary memory or a secondary memory. Can anybody please tell me? Is a RAM a primary memory or a secondary memory?
Primary.
Primary,
Hmm?
primary.
Primary.
Primary. Yeah. So what is the purpose of RAM?
It runs
Okay,
the
tell me.
application.
Runs the application, right? So tell me the difference between your primary memory and a secondary memory, right? So what's the difference?
In the primary memory, like once the system get reboot, we lost the data, but in secondary, the data will be there after the system reboot.
Okay, then capacity wise,
Capacity wise, like RAM is fast compared to secondary memory. That is ROM.
wonderful. Then size wise,
So size is less compared to secondary memory.
secondary memory. So RAM has a limited memory. So but whereas secondary memory has a larger memory. Okay, so as your friends are telling, right? So they're all the answers are perfectly fine. Let me put like this. So RAM is an volatile memory, whereas the secondary memory is a non-volatile memory. Am I right?
Yes.
Yeah. So what does it mean volatile? So if a power until your power is on, your data is present in the memory. Once the power is gone, so your data gets erased, right? So that is the difference between volatile and non-volatile. The secondary memory is a permanent memory, whereas the primary memory is a temporary memory, right? And as the capacity of the RAM increases, your processing ability will also increase. Your processing ability will also increase. Am I right? Jagdish Kumar, you said something? Jagdish Kumar. Okay. Yes, fine. So if the RAM capacity is more, so that means you can load more instructions and you can run faster. Secondary memory is a permanent memory. It is large in capacity, but it doesn't help you to speed up your execution. Okay, so the performance level, so it's varied according to that levels also, since the capacity of the RAM is also more and clock speeds are more and the capacity of the processor is also increased. So obviously all of them will have a the performance wise better, right? So pi 1 is very basic and entry level multitasking is allowed in pi 2 and good for general use, and then desktop your classes defined with the clock speed and the RAM's capacities, and come to 5, so it is even more advanced, which is going to be 2 to 3 times of force for the pi 4 performance. So power efficiency, which the Raspberry Pi 1 model is very low, whereas it will be little taken care in the Pi 2 model, which is said to be improved, and then Pi 3, which is uh, better comparatively, and Pi 4 is high in uh, performance and optimize perfect per watt. So it will be far better compared to all others. So IO expansion, so will be general purpose IO pins are there. So improved IO pins are there in Pi 2 and Wi-Fi and Bluetooth was introduced in Pi 3 and USB 3.4 and dual HDMI has been introduced in Pi 4 as well as this went on and PCI 2.0 which compared to the IO operations which is very fast. Okay. Now, when they compare this, what are the best use case for this? So, where Raspberry Pi is better to just to explore it. Okay, so as a learning basics, where Pi 2 will be used for small projects, which also for the education purpose. Pi 3 is it is improved version which is supporting IoT and media center. So Pi 4 is development and desktop, and Pi 5 comes with the latest technologies to be adopted with AI, robotics, edge computing, and many others. Okay. So the year of release is 12, 15, 18, 19, 23, respectively. Okay. So Raspberry Pi 4 model, which is a B model. So specifications and description of each of them, which is also known as RPA and Raspberry Pi. So these are the release dates 12, 10 years ago, which has been started, and then 19 it has been introduced. Right. So these are the prices of them, which varied with the capacity of those devices or the RAM capacity, which can run with a different operating system. It can be Linux or FreeBSD or NetBSD, OpenBSD, or it could be Windows 10 or Windows 11, sorry, Windows 10, and which is an IoT based. The processing ability of those systems, which is system on chip, right? So which is the main heart of it. So which comes with a Pi 3A plus, which is a Broadcom BCM 2837 B0, where a P5 Pi 4B will also has a BCM 2711 B0. So Broadcom BCM. The CPU clock speeds are also given with comparison. Pi 3A will go with 1.4 gigahertz and with a quad core A53 64-bit chip, whereas Pi 4B will be 1.5 gigahertz quad core A72 64-bit. Zero wattage, so 1 gigahertz ARM11 32-bit will be supporting that. The memory capacity of each of these Pi 3 comes with 512 MB LPDDR2 RAM or SD RAM. Pi 4B will be one which is may not be available now. It's stopped. Where 2, 3, 2, 4, and 8, which has more prominent the RAM capacities, which will be used, and with the latest version, it could go up to 16 GB, which supports higher programming models and execute larger applications with faster and studies. So then the zero wattage, so it could be 512 MB LPDDR2 RAM. I3 will be tier 2. Pi 3 and Pi 4 and 01 CM3 will also support the video configuration, which is the graphics, so which comes with the Broadcom video core 900 megahertz. Pi 4B Broadcom with which is the video core 6 with 500 megahertz. Zero wattages or W, which is power supplies compared to this all of them, which could with 5 volts or uh, this is a comparison of these things, which gives more specifications, details of them, which can be referred through raspberrypi.com. So the same structure again, which I'm just showing here. So Broadcom BCM 32635, which is a system on chip, and then next to that you have a micro USB. This is called a system on chip processor, which is a CPU. Broadcom BCM 2835, which is ARM 11 700 megahertz. This is a HDMI cable connector, and this is a micro USB for power supply as well as this thing. And this is a USB 2.0 where this will going to be supporting them through giving the push to things like. So this is an audio output. So where this is an video output. Uh, and I have pins which is ready to be calculated based on that I can. mm, Now this is a generic hardware schematic diagram of a Raspberry Pi. So a core processor will be there. So where it has been attached with a memory, and it is going to be the controller is going to control the every activity of the system. So where you have the keyboard, the contribution of them, is as well as MSD ID. Right? So you have a graphical processing unit. So camera, JTAG, power, radio frequencies for cellular network, and USB and UART for the pen drive connection or anything as such. So Bluetooth and speakers, which is also getting and microphone and then keyboard. So this is general schematic diagram of it. It's a processor comes with, and then you'll have the wireless connectivity with Wi-Fi, or it could be uh, the Bluetooth, or it could be GPS receiver. So where it can process that to the person to accurately predict and tell you what would be the answer, right? So then you have the amplifier, so which comes with a ADC converter, analog to digital converter. It gives you low power noise also. So and it's a sensor signal for reference, which is reference. So other than that, we have the codec, so which is used here. The codec means so coding and decoding, so that from conversion of analog to digital, digital to analog, we'll be using DAC or ADC, through which it's going to amplify that and generate the voice, right? So we'll have interfaces, power systems, power fuel gauge, or CODA, lithium battery production, and battery charger, so which will come into instructor. Sorry. They've all been part of your Raspberry Pi for holding your short time power supply. But the majority of them, it will be running through the AC adapter, so where you will be having a connectivity, right? So this is your schematic diagram. So hardware schematic for mobile phone. So you'll have application processor which is in your CPU or in your platform. So where you'll be communicating, or you're going to irrigate the channel through uh, various devices, which will be flash card or memory card or so this is a mobile phone schematic diagram or the generic states of it. So you'll be active, quiescent, and semi-active, and nascent, right? So when you power on, that device will go into nascent, and then once any action has been taken care, so that your phone will become active, and you can have a hardware reset, so that you can directly shut down it, or if not, software reset. So it'll be going to quiescent. Uh, so where the things will take care, and once it is done, so it will go to the semi-active, where you can think of doing the work or executing the work, and later on by maximum 2 o'clock, so that entire thing should be uh, the components of a mobile phone is that it's going to have a baseband processing and audio speech processing, which is a digital signal processing part of it. And then the device should have a ADC as well as DAC. So ADC for analog to digital converter, DAC for digital to analog converter. So RF part frequency conversion and power applications. So baseband processing and audio speech processing. So appearance of a hardware, mobile phone hardware, so which comes with audio IC, flash IC, RAM, UI module, logic IC, so buzzer interface and mic interface, R222 CPU, uh, VCO, BCI, the RX filter, network IC, and of anything else. The mobile specifications, which goes with the Z Fold, like just considering the latest one, so which has a Z Fold set, so which comes with a 2G band, so which can be CSM, GSM, CDMA, or HSP, or LTE, or 5G. So 3G bands comes with HSDPA 850 or 900 or 1900 or 2010. So to the 100. So 4G bands will come with the LTE bands 1, 2, 3, 5, 7, 9, 7, 8, 20, 28, 38, and 40, 41, and more, so on. So 5G bands will come with this server and speed for 2.4 megahertz millimeter per second, so which can be faster. Uh, which also comes with LTE, a class with CA. So it has a type dynamic AMOLED 2x and refreshing rate, and 1B colors, 1 billion colors are there, 120 hertz for refreshing rate, HDR10 plus camera, and 1300 the net speed. And size is 6.2 inches, 93.1 inch. Excuse me. So the display category of this is type is dynamic AMOLED 2x and 1 billion colors, 120 hertz of refreshing rate, HDR10 plus for video recording. So it can go up to 1300 nits per a peak. So size is 6.2 inches, 93.1 centimeters square. So screen to body ratio it is. Resolution will be in terms of pixels, 1440 into 3200. So 20:9 ratio. So it comes with a production for Gorilla. So platform Android 14 and above. So One UI 6.0 for a user interface. Qualcomm Snapdragon 8 Generation 3 processor. The CPU octa-core, one with 3.3 gigahertz and for 6 and Cortex X4 and 5 of 2.9 gigahertz Cortex A720 and two of them is 2.2 gigahertz Cortex A520. And also comes with a graphical processing unit, so Arduino 750. So there's no expandable memory for this. So internal storage itself will come with 256 or GB secondary memory and 12 GB of RAM and 512 GB or 12 GB RAM. So it can go up to 1 TB and 16 GB RAM also it will be available. So main camera, so it comes with a triple 50 megapixel camera, f1.8 focal length and 23 wide angle, dual pixel PDFAS and OIS 12 megapixel, 22.2 and 123 ultra wide angle. Features which comes with LED flash and HDR and panorama. So video, so it comes with 8K at 224 frames per second and 4K at 380 or 60 frames per second. So like that. There's a selfie camera also comes with. So it comes with a single 10 megapixel camera. So video also have a recording as 4 megapixel for the front camera. Sound, it comes with loudspeakers, so with stereo speakers and many things. There's a sensors which is there, especially for that is most important to understand. So there's a fingerprint sensor. Accelerometer is there, gyroscopic sensor is there, proximity sensor is there, compass is there, and barometer is there. So the battery is another thing. Where for a portable device, that's the most important thing is battery. So which comes with a Leon 4400 mAh battery, so which is non-removable. So it comes with a fast charging, 45 watts, which is for 50% in 30 minutes, which has been said as, but still it will be done. So wireless charging also comes with 25 watts, and reverse wireless charging also comes with 4.5 watts. It also comes with connectivity, right? So it can connect to the wireless LAN, so Wi-Fi 802.11. So which also comes with variations. So A, B, G, N, AC as well as 6E. Dual band also available. Wi-Fi direct is also there. Hotspot is also there. Bluetooth connectivity, which comes with A2DP and LE as well as 5.3 version. So Pershing, so it comes with a GPS, GLONASS, and BDS, Galileo, and many things. So NFC, so it also enables in this format. So infrared ports are not there, radio is not there. So USB, which is also comes with Type C 3.2, and USB on the go also supports. Some of the miscellaneous things, which is color, silver shadow, navy pink models will come. Pricing, it is nearly 1,900 USD dollars, right? So performance testing is done, so which has been proved tested. So all of them are like. So bring in the focus on wireless interfaces, which is most important. So what is that? The wireless standard started from 2G, 3G, 5G, so then 4G, and now we are in the 5G models. So where earlier we were using GSM, so which is a global system for mobile, was the first all digital mobile cellular standards, and the earliest one still in widespread we are using today. So GSM is an ETS, a European Telecommunication Standard Institute, so which a standard originally intended to be the first European digital cellular standard to support international roaming. It is based on TDMA, so which is time division multiple access. So this group was started in 82, so and allocated the spectrum at the range of 890 to 915 megahertz and 935 to 960 megahertz. So the standards which we are talking about today, so 2G, 3G, 4G, and 5G. So their comparison is given with various factors, right? So year of introduction. So 2G was introduced in 82. 3G, which is UMTS or WCDMA. So all of them were introduced in the early 2000s, and 4G was introduced in the late 2000s. 5G 20s onwards, right? So this has been started, but nowadays the 5G is completely available, right? So key technologies behind them. So for giving the access of this things, right? 2G was using TDMS, which is, as I mentioned, time division multiple access. So 3G was using WCDMA, so wideband code division multiple access. So 4G was using OFDMA, so orthogonal frequency divisional multiple access. And 5G was given new radio, so which is the wave at sub 6 gigahertz, right? So the frequency bands for them, as I mentioned, for 2G it is 890 to 915 megahertz, whereas or even 935 to 930, 960 megahertz. But whereas 3G was 1.9 to 2.1 gigahertz, right? So 4G was 700 megahertz to 800 megahertz and 2.6 gigahertz up to that. So whereas 5G, it is below 6 gigahertz, right? And 24 to 100 gigahertz, which is also available. So dual speed, so which can go up to 14.4 kbps, 384 kbps to 2 mbps in 3G, 100 mbps in 4G, and 10 gbps in 5G. What are the key features supported in those the versions, right? 2G, which is for first internet connectivity through mobile. Okay, first digital mobile network, primarily for voice communication only what was used, as well as it was able to have a communication of text messages as well as MMS, multimedia support. And in the 3G, it supports the enhanced data transfer for internet browsing, so support for video calls and multimedia services. For a 4G, it gives you high speed for HD streaming and voice over IP, supports mobile broadband and IP-based communication. 5G, it gives you ultra high-speed internet and low latency, supports low latency, which supports the IoT devices, smart cities, and which is autonomous vehicles also. Enhance the mobile, the virtual reality, and things like augmented reality. So 3G WCDMA UMTS, so it is a Universal Mobile Telecommunication System. So UMTS is a widely supported or a 3G network. Wideband CDMA was used, so it is for an interface for UMTS. It was created by 3GPP, third generation partnership project. So it is based on CDMA transmission, which is defining characteristics. So it is designed for advanced 2G cellular network. Standard is to enable the transmission of high quality images and video or wireless connections with the aim of eventually enabling IP-based broadband services. Its original goal was to design a single third generation air interface. 4G WiMAX, so worldwide interoperability for microwave access is a 4G wireless cellular standard. It belongs to IEEE 802.16 group of standards for wireless metropolitan area networking. IEEE 802.16 established to develop an air interface for wireless broadband access, which is focused on a point-to-point standard. The standard employed a single carrier physical layer and employed burst time division for multiple access at the MAC layer. So this was subsequently expanded to 802.16a up to P also. Bluetooth is a communication wireless communication medium, so where it is designed to be a low cost and low range as well as requires less power supply. So the Android platform includes support of Bluetooth network stack, which allows your devices wirelessly exchange the data with the other Bluetooth devices. So Android API can perform the following, so which can scan the Bluetooth devices, query the local Bluetooth adapter for pairing up, establish the communication channels, connect to other devices through service discovery, transfer data to and from other devices, manage the multiple connections. Then the other communication mediums are like LAN and NIC, right? So LAN and the internet. So every device will come with mobile devices, especially will come with connectivity, right? So which could be LAN, so for LAN port for internet connectivity or network connectivity. So CAN port for hosted model support, which will be there. So where you can go for a local area network, which can span for maybe within a building, right? Where you can have various devices get connected to that with the various topologies, such as the ring topology, bus topology, star topology, mesh topology, or hybrid topologies, right? So where we'll be using various devices in order to get connected to that with the help of our switches or the routers and many other things. So it's a USB is another thing which is called as Universal Serial Bus, an industry standard developed in the 90s. So which defines the cables, connectors, and communications protocols used in a bus for connection, communication, and power supply between computers and electronic devices. The USB IF cable certification program aims to provide USB end users with a list of cables that meet quality standards necessary to operate in a USB environment. Right, so that's it from my end for today's session. So, if there's any questions from anyone, please let me know. I'll just try to answer your questions, ensure that it is